Cool. So we're going to talk today about language servers in code editors. Specifically, those of you know me, I use Vim as mine. So Vim features very heavily in my presentation, but it is not the only one. There we go. So most of you know me. Dang it, get out of my way. Okay, sorry, there's a Zoom window in my way. Most of you know me. My name is Tavis Aitken. I'm a principal SRE at Splunk. I run this particular meetup, which is the Denver DevOps, but also the DevOps Days Rockies with Nick and a few other folks who couldn't make it tonight, but we're all very excited and hopefully we'll do a DevOps Days this year. You can find me at Tavis pretty much every platform. There's probably some new ones I'm not on. I don't think I'm part of Instagram or any of that stuff, but GitHub, all that jazz, you can find me at Tavis. So what coding tools have we used over the years? This is going to be my journey that I've used over the years, but some of you might recognize some things. So just, a timeline, and this timeline has gotten way longer than I thought it did when I went to go lay it out, because apparently I'm old. So the first thing I ever started writing code was Borland C compiler on a Blueberry iMac in 1999. My first exposure into like coding and all of that other stuff. And it was a really interesting experience learning to code using like a whole IDE suite at that time. Like going and learning Linux after that and then doing GCC and other stuff afterwards was a different experience than using that. But the IDE definitely gave getting started a little bit extra of a kick, and it gave you resources that you wouldn't get unless you had some sort of tool that gave you good response. So after struggling along with, Notepad or whatever, in college, we all had roaming profiles on a Red Hat machine, and we had this editor called Nedit. And it was the first time I'd ever seen syntax highlighting. So Borland was great, but I don't remember there being syntax highlighting in it at all. Like it might have, but I don't remember it. But maybe I didn't have it enabled or whatever. But Nedit was cool because it was like a cool little Notepad app, but it understood what my code should look like and what it would highlight, like variables and all kinds of stuff like that. With C, that's all kind of nice because all the variables are prefixed with something. Python gets a little tricky because there's no denotion of a variable from a string. And we'll get to that in a bit. When I started doing like professional web development, I used Zen Studio, which the original Zen Studio was its own weird Java application. And then they switched to Eclipse and used Eclipse backend. And I remember using Eclipse and dealing with Eclipse plugins and kind of all of that stuff. That's some of you may remember doing all of that, and fighting with Eclipse to get it to do what you want and like automatically highlighting things. And that was the first time I was able to debug something live in the editor, which was a pretty neat trick. Like you could say, set a breakpoint, compile your code, run it, and then it could go back to that breakpoint and show you all the things about it. Now there's always command line tools like GDB and stuff like that, but this was the first time it's ever been baked in the editor for me, which I thought was really exciting. Then I got into reading the Pragmatic Programmer book. And the thing I got out of that was that you should pick a tool and learn to use it really well. And what I got out of that is I should find a tool that is ubiquitous in every platform, everywhere you're going to use. As kind of a systems person, I was able to get onto servers and like I was SSHing to lots of places. And one of the editors that was everywhere was Vim. I know some people would suggest things like Nano or Pico or anything in that line, but I've never really figured those out. The key commands have always been weird to me. So BI is everywhere. Specifically the Vim variant on Linux in most of the distros I've been part of, but also like I had to do AIX servers at one point in my career, and the actual VI from, Unix or AT&T Unix was on there, and not the Vim variant, which was mind blowing. So then like I started to figure out, okay, I like Vim, but I also like all of these features that all of these other editors have. How can I put those into my Vim configs? So I put my configs in source control. I started trying to play with a lot of plugins and try to figure out how to do things. One of the downsides of the way that Vim used to work, though, it was all very synchronous. So there was no good way to do an asynchronous action in Vim. There was a couple of weird little tricks you could maybe kind of do, but like everything predicated on like saving the buffer and then running a command. So you could run like make in the background, and make would run, and then it would pop into the editor with some output. But it wasn't really synchronous. Some of the later plugins, as we kind of like progressed, like AL would run your linter in the background and then start to pop in. But again, all of that stuff was pretty slow. Like Vim script was the way that it was all written, and it was all pretty slow. So kind of like as I started doing that, I figured out how to do PHP debugging inside of Vim. Again, it was a little weird, but I got it to work. It was very asynchronous and not very stable. I remember trying to show it off to a bunch of coworkers, and they were laughing at me because it was horribly broken when I tried it, because I had recently did a brew update or something and completely broke everything. So debugging inside of Vim was not easy. There's a plugin for Python called Jedi that I started using that was a little bit better, and that did some interesting things that I hadn't experienced on a language level, like auto completing, and doing things like scanning your actual code for variables, functions, things like that, and then being able to inject those back into your code. And like if you wrote a comment block on the top of a function, if you ran Jedi and you hit tab, it could show you a little snippet of what the method signature was like. It was still a little clunky and thing, and it like fired up a whole Python environment underneath, and you had to compile Vim with Python support so that Vim could run Python inside of its own process. So instead of like firing up a sub process, it was like kind of built in, and it was kind of not. It was a little weird. There was versions for Ruby and stuff like that, but it was still a little weird. And the first time I really got into doing async stuff is the Vim Go plugin. So the Vim Go plugin it kind of wrapped a bunch of this stuff up for Golang, and you can kind of see which languages I was using at the time as my career progressed by which tools I'm looking at. But Vim Go allowed me to do things like debug and some of that stuff, but it was still pretty rudimentary. Like it's kind of slow, and it like shelled out to a bunch of stuff and exec and came back and tried to do stuff in the background. But until about 2016, 2017, Vim didn't really do async very well. 2017, there was a fork of the actual Vim code, and I'll get to the history of Vim in a minute. But that fork allowed for async. And the async and like being able to spin up processes underneath really unlocked the door to do all of that stuff that some of those other IDEs have been doing for years, which is kind of funny for a tool as old as Vim to not be able to do some of those things. But it was intentionally like kind of simple. So now, I switched through CFC Vim, which was a whole bunch of JavaScript pain, and now I use the built-in LSP server into Vim, and we'll get into what that is in just a second. And I'm going to just super speed through the next one, which is, come on, there you go. Just the history of VI, mostly because I'm really a nerd about Vim, and I've chosen this tool. So what is it, and where did it come from? Basically, the VI variants have been around as long as almost all the code we've been writing. So in the early 70s, Ken Thompson, who wrote C, needed an editor, so he wrote Ed. Ed was incredibly hard to use, so somebody wrote M, which was an editor for mortals, because Ed was impossible to use. Bill Joy, when he was working on BSD, picked that up and put a visual thing on top of it, so there was now a visual mode. And then all of that got bundled into the very first BSD. and then got kind of pushed in, and then VI was built into that, and all of that was included in all of the AT&T Unixes. So all the early Unixes all had VI, and that's why VI is now still this part of the Unix standard. So if you're using any Unix standard thing, that you will have a VI compatible editor. Now, what that is totally up for debate, and is probably not any of the original code for any of those original editors, but they function the same way, which has always kind of been fascinating to me. In the 80s and 90s, there was a bunch of clones of those because of all of the closed source nature of Unix. So AT&T and SCO and all those other people wouldn't get their source cut out. So people basically rewrote the same functionality in clones. So there's one called Stevie that was first written by Tim Thompson for the Atari. He was working on an Atari thing, and he needed an editor, so he went and wrote that stuff. Elvis was another one, and Elvis was the first time there was color syntax highlighting in any of these editors. And if you notice, like that's already in the 90s, so it took, 20, 25, 30 years to get syntax highlighting. And the one that we all have been very familiar with was written in the 90s for the Amiga, actually, amusingly enough, and then it's been ported to pretty much everything else after that. And Bram Moulander still maintains Vim to this day. And it's always funny going back through coding history, because all of these people still work on these projects and are still alive and talking about them. So basically, like, that one's been added and has been progressing slowly. Like, there was a while there where, code completion got added in like 2006. And it wasn't until there was a fork. So NeoVim was a project that was kind of community based, because Bram didn't want to deal with async and thought it was not worth his time. And so the community forked Vim. So NeoVim is not it's a new code base, but it was started with the original code base and then completely refactored. And the whole idea behind NeoVim was to break apart the commands and how it worked into an async way, and to be able to run things asynchronously behind the scenes. It took a lot of what the things that like Node.js and some of those other like big async projects were working on at the time, and build those ideas in. So like NeoVim, you can run the back end of NeoVim and a different front end. For example, there's a Visual Studio Code backend that runs NeoVim natively underneath, and then just uses the input and output in the visual mode to do all that stuff. So, and then like as the language servers kept getting adopted, the NeoVim folks were super excited about that, because it fit into their async model, and they built it into NeoVim itself. So they have a LSP. There was a couple of LSP servers that were able to talk to it on their own, but then NeoVim now has it built in natively into the code, which makes it significantly faster than running a Node.js project, inside of another thing that gets shelled out to. It's now native into NeoVim. So I've said this word LSP a bunch in language servers. So like, what exactly is a language server protocol? Essentially, it's a abstraction layer for the language servers. So the language itself can be broken down and run completely independently of whatever editor you're using. So it's basically uses a client server model. Usually it's a socket. The editor and the backend server can talk back and forth in a standardized way, and there's a full specification. It's all JSON, it's all UTF-8, and it's allows you to talk to a backend that is not necessarily included in your editor, which allows a lot of really cool things, right? Like, so you can make a new language, and if you make a language server, all of a sudden every editor has full support for your language, and you can even do all kinds of stuff. So like, what's the deal with this? Who came up with this? Like all good standards, it was created by Microsoft, but they created it for their Visual Studio. And Visual Studio is one of the more impressive projects from Microsoft I've seen in quite a long time. Honestly, like, it's a very nicely put together editor, and like some of the things that like Sublime and Atom were doing VS Code took and just rocketed it way above. And I think the language servers had a lot to do with that, because they defined a spec, they defined a way to do a plugin, and they defined a way to do that like modularly, which means that you didn't have to wait for Microsoft to update the bindings for your editor. And yeah, so like the idea of standardization is huge, right? Like no matter what we do, like when there's a standard, as long as there's not 14 other competing standards and somebody creates a new one. But if there's a new one and there's 15 standards, but only one of them is really useful, that standard will win. And winning is always a little relative, but winning is basically like adoption. So what editors support these things? So in the last couple of years, a bunch of them like Eclipse, Vim, like I said, has got async. NeoVim with their fork definitely was able to do it. All the JetBrains editors now support language servers, even though they've kind of got their own version as well. Emacs has one, Sublime has one, Atom has one. And of course, Visual Studio, because they started with it. And the marketplaces for those are varying levels of complicated to install. And getting language servers to work in vanilla Vim is a little tricky. Getting it to work in Visual Studio Code is as easy as like when you open a file it doesn't know about, it says, do you want to install this language server? Some of the other ones are varying amounts of complicated. I've never actually used Emacs, so I couldn't tell you. So most languages that everyone uses probably has one that you've heard of. Microsoft went and preceded a bunch of these, so there's usually a couple of versions of some of these servers. Python's got one that Microsoft wrote, but there's also Pyrite. There's a couple other ones. Actually, Jedi Works has a backend one. Golang has a really good one. That's that Vim Go Plug-In talks to the backend Golang Go PLS. Ruby's got one. I actually couldn't get that to work because I haven't done any Ruby programming in quite some time. But like there's one for Puppet, there's one for Terraform, there's actually a Bash language server, and there's a whole bunch of irony about installing a language server in NPM and running a whole node stack and able to debug your Bash code. But there's a YAML one, because we're all YAML herders. There's even JSON ones and a bunch of other like formats and all kinds of random, like I said, like I mentioned the Rust one. But what does it do? So like we have all these language servers. What's the point? Like we have some of the capability already. Why do we reinvent this? Well, what it allows you to do is to centralize like linting and autocomplete and navigation of a code. So way back when I was doing PHP development, I used to have to like shell out and run a ctags utility that would build a tag file so I could navigate my code. And I'd have to redo that anytime I'd save. That's a huge kind of pain in the ass. And it's especially on big, large projects, that would take a couple minutes because, computers are always getting faster, but then you build more code and you put more garbage in it. So it goes slower again. But like having something real time that's either indexing that or has it in memory already and understands what your editor is doing with a communication protocol is very powerful. So going to definitions, finding instances of a variable and being able to highlight them in your editor. Anything specific to a language that does autocompletion. So we all Microsoft used to call it IntelliSense. I think IntelliJ had a fancy word for it. Eclipse had like some fancy stuff. And some of it was like weird and clunky and slow. And like, say the language got updated with a new function, or you download a library and like it wouldn't update the autocomplete because there wasn't a new version of the Eclipse or whatever. With the language server, that's all handled like completely outside the editor, which makes it really nice to be able to do. So who wants to see a demo? So first off, can everyone see my terminal screen, and is the font size good? All right, good enough. Wave me down if it's not good enough. So as you can see right here, I have a just a quick little demo with a couple of languages in it. I have some Bash, some Go, some Python, some Rust. Those are like the ones that I could easily get to work, and I don't think we're gonna only have time for a couple of these. So first off, I'm going to start off with the Bash ones. So first off, I'm like, okay, that's not super fancy. It's syntax highlighted. That's nice. Cool. But now if I save it, holy crap, what is that? So this isn't necessarily the language server. And there's a difference between some of these things. Some of the language servers won't do some of the linting for you. This one is actually using an external linter called shell check. But it allows you to see errors like this in the margins, and then like that this variable, and it does some other stuff, blah blah blah. But it also allows you to do some really cool stuff, like like, oh, I always mess up how to do an if statement in Bash. So it allows you to do a snippet, and it can show you the example of what the snippet is about to do. And you can kind of see in the thing here, you can be like, oh, here's some man pages. Like all of these things are coming back from the language server. So it's saying as I'm typing this stuff, it comes back with this data and it displays it in whatever way the UI is doing it. And in this case, NeoVim is doing the UI and rendering it in these little panes. So if I hit tab or enter on the snippet, cool. Now I do the if, now I can do my thingy. So whatever, all that kind of fun stuff. Oh, hey, look, did you forget a $sign somewhere? Because I didn't actually do a condition. So now I can use some bar. Yay. Cool. Neat. So that's kind of Bash. And that's like, and if I just background that, you can see, well, we're going to see ahead of here shortly. You can see one that I'm running this in Visual Studio Code as well. But also you can see that this is now running a node npm server that knows about Bash. And it's connected that socket with my NeoVim session. So let's look at the same thing in Visual Studio. So again, exact same script. This is the same folder and everything else. But let's go back and delete that again. So now, hey, look, we're using the exact same shell check program and the same servers to give us the same kind of information. So two very different editors with very different like display patterns can use the same information. And all kind of the same thing. Like, so the if and like how some of this works. And you'll have to excuse me because I don't use Visual Studio Code like ever. So I don't know all the key commands and stuff like that, but you hover over it, you get the information back. It's kind of the same thing. Like the language server is doing the same thing. So let's look at a little bit more complicated example. So this is my Go project, my little Go thing. So you can see here that I have a folder with another Go file in it and a main. And it's saying, cool, I'm going to import format and all this other stuff. And it's like, all right, where am I using format? And notice that it's highlighting all the places where that import is used. Like that is all using the import, the back and forth about how it works. And then like, all right, cool, print line. Now let's say I want to print something else. Oh, now I can do print f, print line, and it shows you all the different like bits and pieces of where that came from. And all of that is talking to the same mechanism. It's just a different language now because it's full of different stuff. So you can say like, oh, we can do like scan f and read stuff and all kinds of fun stuff. And again, like if I do a thing that's wrong, this is now running the linter through the language server as well and telling you, hey, this isn't declared, none of this works, like what are you doing? That kind of thing. But it can also has a neat trick of like, okay, so right now on my keyboard, I'm just going to type GD, which is go to definition. So go def, where is bar defined? Boop. So what that did is it grabbed the tag of where that is defined and opened the other file. And now I can like look at stuff in here. I can do all this stuff. I can see this. And then in NeoVim, you just hit, Control T to navigate back using the normal tag function that's built into VI for decades as the normal tag stack, except it's like auto-populated with this asynchronous tool. So I can go, back there. Like, all right, well, that's neat. How about debugging? So let's go back into our bar and let's say we can see, oh, look, there's a whole bunch of debug things. So let's set a breakpoint. Hey, look, it showed us set a little breakpoint. That's pretty neat. Let's go back to main, and now we can go debug. Ooh, that's a bunch of fancy stuff. So what do we got going on here? So what this is doing is it's talking to Go PLS under the hood. So we'll see one tempting fate by zooming out of there, but so we can see that the Go PLS is running a couple of things. It's running the language server, but it's also running a debug server and inline reading the code and the debug symbols that it compiles, like kind of in real time. So cool. Hey, look, it stopped at our breakpoint. That's really neat. Oh, there's some stuff starting to go on down here. We can see registers filling up. This is hidden entirely by my color scheme, which is always fun when you find that out. But basically that's just showing you which files are being accessed, all that kind of stuff. And then down here we can see registers and Go routines, and then like the actual like super like low level output debugger. And then you can do Go debug step. So I can do one step down, and now, oh, hey, look, we can see our local variables. All the stuff is super useful when you're diving through code. And there are key shortcuts for all of this stuff. I'm just not using them at the moment.
That's not nvim DAP. That's something else. You said that's a Go debugger.
That's yeah. So it's Go PLS is what that one is, and that's part of the Vim Go plugin. So Vim Go has a whole bunch of suites, and that includes like dealing with the language server properly. So that's Go, and obviously that's a pretty contrived, simple little example, but it's a pretty cool little sweet thing. And having it working and being able to like step through Go code when it's doing stuff is super handy. So now I don't have Go debugging working in Visual Studio because I just don't spend that much time there and I didn't get it to work. But we can definitely see that the Go server is the same thing. So it's the same information. It's the same kind of like language server stuff. And, like say we take out the print line, it should, no. Oh yeah, there it goes. It should take out the import format for me, and I believe it even takes it out of the Go mod. Oh no, because we're not actually importing it there. That's fine because it's built in. If we were doing an import from a GitHub repo of a third-party language, they can like manage all of that stuff at a project level for you too. So, same thing with Python. Python is running, so under the hood. Again, there's something ironic about running an NPM node server to do Python. Interestingly, like I thought Pywrite was the one that Microsoft wrote, but theirs is called PyLance, I believe. And that's the one Visual Studio Code is running. But again, kind of same deal. Like we have an import, it's from a thing, and you can go to the definition. Maybe, no. And this was working. Again, I don't use Python very often, but GD. Nope. All right. Well, figures. Demos all the time, every time.
I think GD GoDef is a part of the GoPLS.
Yes, it is. GD is actually what I have remapped in the other thing to GoDef in every language server, but I may have broken that at some point. But so the other neat thing is inside of NeoVim with their new language server, you can see what language server is connected to. So it's like, all right, neat. With this open buffer, I see that it's a Python file. I'm going to auto start this this language server. Here's all the ones that are configured, et cetera, et cetera, et cetera. You can also, there's another plugin called LSP install. I forget now. So I can say, which ones do I have installed? Oh, look, there's some new versions installed. There's a new Pyrite. Let's update it. Man, I updated this like this morning. All of this stuff moves at lightning speed, which means, of course, that it is a little unstable sometimes, which is fun. But this can do the installing for me. The way this particular plugin works, everything is in its own little folder, and it handles the install. It can install an NPM, Ruby gems, Python packages, and a couple other ones. And it like adds them into the path and does some other magic under the hood. It's pretty slick. But that also means that it's all in your editor and everything else, and you don't have to go screwing around in your Vim init file in this case. Of course, once you've done that, yeah, so Pyrite's not running anymore. Let's see with the new language server if this actually works. Now, if I go here, GD, no, I broke that key command. There is a go to definition somewhere, but I broke the key command, so that's fun. It's again what you get for messing with stuff before you demo. Oh, one last thing I wanted to notice is Vim, for the longest time, since it was written as a C compiler tool, has had a makefile loop built into it. So if you do make, the make program you can set dynamically. But by default, it's set to make. So if you have a make file in your project and you run make, it'll just run it, which is super handy. And it has a little output and all that other stuff. And I don't have it set up here, but if your make file does a build and it spits out an actual file in the correct format, your editor will just go to that file and that line where it broke. So instead of like running make and like seeing the output and copying, pasting the line and the thing, you can just go directly there, all inside your editor. It's pretty big, and it's like reminds me of using Eclipse or even that Boiling C compiler when it would compile break and you'd see like nice big warnings. It's better if you see the warnings before you break it, but so that's Python. And again, we can go in here and look at the same code. And this one, okay, yep, there we can see bar function, blah blah blah. And we go into our example, bar, oh, look, that's the same function. And this one, that actually works because control click actually always works in Visual Studio. If you know the key commands, it works in Vim too. I just broke them all. Now, Visual Studio, there's a way to do the makefile loop. I just don't know what it is because I don't use it very often. So let's look at Rust. While we're in Visual Studio, we'll just look at Rust. Let's open the main Rust file. So again, here it shows your encoding. Oh, and there's a zoom window on my way. Go away. There we go. So down here, it shows the Rust file, and it shows you what it is. You can configure your Rust-based language settings. So there's just a JSON file that controls all this stuff, and it tells it which interpreter path to use, auto fetch, all that kind of other fun stuff. Yeah, no, I don't want to mess with that. In order to deal with the extensions, and this is what I didn't really show you, is they built this pretty handy dandy little like marketplacey type thing. So I can just search for Rust extensions. Now, the real problem that you run into, the Rust analyzer is the one I want to use because that's kind of the standard one, but there's also like a Rust plugin. And sometimes they fight. Like if I went to go install a Rust plugin, let's see if we just install it. No. Does this now show me the thing? Nope, doesn't show me anymore. All right, last time I did this, it told me like you can't have both of these installed, they'll fight each other. Apparently that's gone now. That's fun. Yeah, but then you can see like there's all of these other different plugins. Here's where the nice little market. So this is where like Visual Studio has got this like figured out. It's got nice little logos. Like for getting started and people who are just getting into this stuff, like it's really nice. Like, oh, I'm going to use, you know, I don't know, what's a shiny new language everyone's learning.
Dino?
Dino. Dingo?
It's newer. Dino. D-E-N-O.
D-E.
The guy wrote Node wrote this now.
A language client server for Dino. So there you go. Neat. Cool. Right. So that's what I got for Rust. And just to show you that it's the same thing. Cargo. Same kind of thing. You know, here's foo, there's a thing. Down here we can do, and it'll show you your function definition that it's like, oh, it's going to return a string. Hey, look, it's missing a semicolon. That, and it's like, hey, maybe this is an internal variable, like all of that kind of fun stuff. All right. So that's all I've got for language servers. And I hope everyone learned something and got something cool out of it. I want to give credit for all of the slide carnival stuff, because if you need to make it cool things, got to give them credit. I have a bunch of stuff in the slides, and I'll make the slides available after the thing. Basically where I got all my info from for Vim, NeoVim, Visual Studio, language servers. The language server protocol is very interesting if you're actually interested in looking at how it works. It's all JSON and very, very well structured with headers.